We deliver lead time to maintenance. And basically what we're doing is we're catching minor issues before they become major issues, which then could lead to catastrophic events. Typically, minor issues can be solved up tower, as opposed to major issues or catastrophic events will not be solved up tower. And then you would have to get a crane on site, which is very expensive. And then the downtime of the turbine is very long. Minor issues are usually solved in hours or days, while major issues are usually solved in weeks or months. And obviously the turbine is not producing when it is down. So if we can avoid down tower repairs, unnecessary downtime of the turbine, that's what we prefer. High quality measurements would start with the hardware, and that would be the transducer and the data collector. For different machines, you would use different transducers to do the job right. As for the data collection, you can basically have two types of data collection, and that would be offline measurements and online measurements. Now, the offline measurement is typically done that you have a handheld machine and you climb the turbine, you mount your sensors on the drivetrain, and get a single snapshot of the actual condition. Now, this provides the user with a somewhat knowledge of the condition, but the overall condition is still unknown because you don't know how the previous condition has been and you don't know how it's progressing. The other type is the online measurement, and this is where the data collector is mounted in the turbine and it's constantly measuring. This is what we call the CMS. This is the alarm system. It pre-processes the data and breaks down the data into different information and sends it back home. Different descriptors, which are our measurements, these describe the components down to the subcomponent level actually. And when we see these measurements increase, we know exactly what component is failing, and then we can communicate that to the customer, enabling him to troubleshoot the problem in the minst amount of time. So not only are we saving the technicians time in the troubleshooting process, we're also making sure that we are on the right component as well. We do translation of mechanical vibrations, and we do this first by defining the problem in the machine. We need to know and understand how this machine breaks down and how it operates. Once we've defined the problem, we then, through our alarm management system, we design measurements to detect these problems. Once we can detect these problems, then we will deliver the information to the technicians on site so they can correct the problem.